Hi, I'm Soren Deal, and this is my ist361sprint1 application demo. As you can see from my estimates versus actuals here, things are not going quite as planned, primarily due to backlog item number 6, which is learn CRUD in Vaadin. And it turned out there was not a lot to learn there. Vaadin primarily handles view. It does not, data-driven views is what Vaadin is for. It does not interact with a real backend like a database, RDBMS server or anything like that. So yeah, that left a pretty big gap in my plans for this sprint, which was to find a real backend solution. I looked at a few different things. The one that I probably spent the most time on without using was Hibernate, which is another web framework for Java that is an ORM, an object relational mapping framework for essentially abstracting away SQL. And I worked with it a little bit, but I really didn't like what I was seeing, mainly because I think it's kind of backwards in a learning environment to abstract away SQL, since SQL is so integral to modern applications. I think it's better to learn how to use SQL and leverage its powers versus abstracting them away and finding an overly complex way to represent them in an object-oriented fashion, which is what Hibernate seemed to be specifically for. Yeah, the other option I considered is one that I have used in the past, which was to create Java container classes and database utility classes that sort of you call the database utility methods to pull the data from the database, and then use the container classes to pass that data to, in this case, so they would be passed to your controller and then subsequently view. In this case, that would be Vaadin. So I didn't want to do that for a few reasons, even though it probably would have been faster than what I did. And that's the main one, is that it's clunky, and also it just ends up being error-filled either on the database side, or what I usually see happen is developers skip enforcing database integrity, database level data integrity, and then you avoid those daily errors of getting, violating queries, violating database constraints, or updates violating database constraints. But then at some point someone does something, runs a script with an error in it, or something like that, and you lose data integrity, and then things become a real mess. So I wanted to take this opportunity in this class to learn a better way to do this. And so what I ended up doing is using Juke, which is, they call it a lightweight SQL mapping utility that implements the active record pattern. And I had read a little bit about the active record pattern. It makes a lot of sense to me. Anyway, that's out of the scope of this video, but I really like what I'm seeing from Juke. It seems to emphasize SQL knowledge rather than abstract it away and try to represent it as object-oriented programming knowledge. It also massively reduces the verbosity created by JDBC SQL solutions, raw JDBC. So yeah, so I'm using Juke and Vaadin, and to use them together, the best way I found to use them together involves using the Spring framework, Spring Boot specifically, and that's because there's a lot that I don't know here as a novice developer, and there are demos and help, and Spring is so ubiquitous. I had heard about it a little bit, read about it a little bit before this class. I had been hesitant to jump into it because it does implement inversion of control and dependency injection, which I am not entirely comfortable with as concepts. I'm not entirely sure what's what inside the Spring framework. So I will show you my code and how it's working now, and talk to you a little more about what's going on inside of it afterwards. So what my demo does right now, and this is actually it's live, what you're looking at is a table presented through Vaadin, through the Vaadin framework, and this is, I've controlled the columns a little bit. You're not seeing all the columns in the table, but this is essentially all of the games in my database. My database tracks Steam published games, and these are all of the ones in there right now, which is kind of sad because Steam has 12,000 plus games, and this table has 20 games. But that's because the scripts right now are set up to just scrape new app IDs, but I haven't set up the cron timers to run those scripts regularly. So this is just from me running the scripts manually. This is what has come through. And you'll notice there's no game title for most of them and no price. And that's because separate scripts, which do exist but again aren't on cron timers, are set to pull that data from a different resource. The app ID is scraped directly off a web page, whereas the rest of this is populated by an API. So yeah, so I still need to do that, and these games are just too new for this data to exist in the API that I'm pulling from. So I have to wait a little bit to do that. But you will see that this game is here. I entered it manually, mainly for this demo, pretty much. And what you do is you just type, you type a name in here, and it will search my database for a game with that title, and you can find the application ID and in this case the price. But again, this is just so I have something to show you, and not so much a finished product by any means. So now let's take a look at my code and how it's doing this. So worth mentioning, pretty cool. This is my Maven configuration file, my POM XML. Maven helps dynamically manage a class path and all dependencies for a project. I love Maven, it's awesome, but that's out of scope of this video as well. So what's happening here, what's worth talking about within the Maven configuration file is this plugin right here, which is the Juke CodeGen plugin, and it's using data from my Spring application properties, and one of the main reasons I did this is to mask my database name and password, just because I don't really want that floating out there in some point in the future. So anyway, so what it's doing here is it is scanning my database, mapping my database, and it prints out all of these files, which go to this directory: source, main, Java, and then com.steamstart.juke. And so you're going to see that here. And so anyway, this is basically a Java representation of everything that's in my database, or at least the files needed to manipulate that data. It doesn't actually contain all of the data; it just contains the templates. So anyway, let's go look at the view file first. So this is my view file, which, as you can see, it takes the Spring UI annotation and implements the Vaadin request and a bunch of Vaadin UI features right here. And this is actually what's happening here is Spring is automatically mapping this this database utility that I created to this private variable. That's what the auto-wired annotation does. I'll talk about that a little more in my in this actual title query.java. But so what I'm saying here is that I want a grid of Steam game records, which are rows of data from my Steam game table. And then in the init method, I am creating a text field with the name called filter, and this is the display for that text field. And then I'm adding a change listener, and so every time someone types something into that text field, the grid will be updated. And here I'm defining what columns I want on this grid of Steam game records. Steam game record has a whole bunch of stuff in it. It's not just these 3 columns, but I'm saying I only want to display these 3 columns. And then the update grid method calls this database utility that I created, and calls the search method within that and searches based on what's in the filter text field. So, and then it sets what's in that grid based on what is returned by that search. So, so yeah, so the database utility is pretty beautifully simple looking, and that's thanks to Spring. Of course, the disadvantage to this is that there's a whole bunch of hidden code that I'm not showing you. Not all of it I understand. But anyway, what's happening here is I'm using Spring to I'm using Spring to automatically create this DSL context item, which normally would take, and I had it before I was using Spring, I had it created by first creating a JDBC connection and passing it to DSL context, but none of that is necessary because of how Spring works. So Spring is just passing all of that JDBC information from my application properties file over here directly into this DSL context item. And then I use that DSL context item to select. And so the select from statement, the select statement in Juke creates a Juke record. But the select from statement will create a table record, in this case of the table you're selecting from. So in this case it's Steam game. And the main reason I'm doing this is because I ran out of time. And as I move forward, I will revert this to a list of records and work with the record object rather than the Steam game record object, because a lot of my queries, most of my queries, will involve joining tables. So this isn't that useful. But if you are looking for data from one table, this is pretty cool. You just return your JDBC, well, your DSL select results, and they automatically are a list of Steam game records of table records. And so what's happening here, obviously, is if there is nothing in the filter, it just displays all of the records. As my database gets bigger, that's probably not a great idea. But for now, it's fine. And what this does is, if there is a little bit of polymorphism, I guess. If there is something in the filter field, it's passed to this function from the title search, which is happening here. It's actually happening here in the change listener. But so it's passed, and then it returns the filter, which is just the title and the %, and like ignore case, which is a pretty cool feature of Juke, is you can use a like ignore case with your where statements. And yeah, so that's how it works, and that's what it's doing right now, and hopefully next week I'll be closer to back on track. I do think I'm going to have to update my sprint goals for next week based on my lack of progress this week, unfortunately. But yep, that's where I am. All right.